Alright, let's take a look at question 19. And question 19, we are being assessed on how to solve radical equations. Okay? Alright, so the radical equation that we're solving is as follows: b equals the square root of 2b squared minus 64. Alright, so to solve this radical equation, what we want to do first is get rid of this annoying radical symbol right here, okay, to make it simple. The goal when solving equations in math is you want to express it in a simpler form first so you can simplify the problem solving process. Alright, so to get rid of the square root, we're going to use the inverse operation. Now, what is the inverse of square root? The inverse of square root is square, so you square both sides. If you square both sides, you are going to have on the left side b squared, and on the right side you have the square of a square root, so these are inverses. They take each other out, and you're left with 2b squared minus 64. Now, when you square both sides of a radical equation, there's a possibility that you might introduce an extraneous solution. Okay? So how do you know if you've introduced an extraneous solution or not? So it's just something to note. Okay? Something to note concerning radical equations. What do you want to note about radical equations is always check for extraneous solutions. Always check for extraneous solutions. This also applies to rational equations, like in the number, what are the previous numbers we did? I think it's 16 or 17. We didn't check because all the options did not involve an extraneous solution. So when you're solving radical equations and rational equations, you always want to check for extraneous solutions. Alright, so always check for extraneous solutions. These are answers that show up in the solution set but do not satisfy the original equation, and those answers must be excluded from the solution set. Okay, so now that we have this, we just keep that in mind, that we squared both sides of the equation to get rid of the square root and might have introduced an extraneous solution, which we will check for at the end. So let's continue with our problem solving process. We want to collect like terms, the variable terms to the left and the constant on the right. So we are going to proceed to subtract 2b squared from both sides of the equation. So what does that give us? That gives us negative b squared equals negative 64. Okay, this negativity is really annoying. Let's go ahead and get rid of it. Divide both sides by negative 1, because we want to get the variable by itself, right? So get rid of that minus, so we have b squared equals 64. Alright, next we are going to get rid of the square using the inverse operation. You notice we did this before. We talked about the inverse of square root being square, so that tells us that the inverse of square is square root. Perfect. So you root both sides. Alright, now something to remember, something to recall. This is very important, but most students forget this, is that when you take the square root of a square, or a to an even power, so a to the n, a square, you're going to end up with the absolute value of a. Or more generally speaking, the nth root of a to the n is always going to be the absolute value of a if n is even. Okay, so don't forget, very important. So we're taking the square root of a square, so this is going to lead to the absolute value of b equals the square root of 64 is 8. Now, why is that? The reason is because when you square a negative and a positive number, you get the same output. Okay, so if you square negative 8 and you square positive 8, you get 64. So that's why we have two answers. Okay, so let's finish this off. Absolute value of b is equal to um, 8. So we can get rid of the absolute value bars by replacing it with plus or minus. What is that? Okay, let's get rid of that. So replace it with plus or minus. So plus or minus b is equal to 8. Divide both sides by plus or minus 1. And you have b is plus or minus 8. So the answer is option 3. Yes? No. What did we talk about concerning the solutions to radical equations? We said that when you square root it, no, when we squared the square root of the equation right here to get rid of the square root, we said we might have done what? We said we might have introduced an extraneous solution, which is a solution that shows up in this as an answer but doesn't satisfy the original condition. Okay, so we have plus or minus 8. Now guess what? Either one could be a solution, both could be a solution, or neither of them could be a solution. Isn't that something? If you look at the options right here, it really tests our attention to that detail, which is to check. Okay, so either both of them are the solutions, which would be option 3. Either the positive one is, the negative one is, or none of them. So how do we know which is extraneous? We have to check or test. Okay, so test for extraneous solutions. All you do is take the answers that you got and substitute it into the original equation to verify that it satisfies it. Okay, so the first one is b equals -8. All right, so the formula is b equals the square root of 2b squared minus 64. Alright, so if we substitute -8 here, do we end up with a true statement? So the question is -8 equals, is it, put question mark here, we don't know yet, equal the square root of 2 times -8 squared minus 64, is it? Well, let's PEMDAS the right side, simplify it completely. We have the square root of 2 times 64 minus 64. Is -8 equal to 2 times 64 is 128 minus 64? Is -8, is it equal to, subtract those two, you get 64? Is -8 equal to the square root of 64 is 8? Is -8 equal to 8? No, that's false. So this particular answer is extraneous. We cannot include -8 as a solution, so not a solution. How about the other one? B equals 8. Do we have to check it? Absolutely. We have to check both of them. Okay, because both of them could be extraneous. Alright, so we're going to substitute that into the equation and we just simplify it. Okay, is 8 equal to the square root of 2 times 8 square minus 64? Is it? Is 8 equal to the square root of so we already did the calculations here, 2 times 64 minus 64. Is 8 equal to 2 times 64 is 128. 128 minus 64. Is 8 equal to, if you subtract those two, the square root of 64? Is 8 equal to the square root of 64 is 8? Is 8 equal to 8? Yes, it certainly is. So this is a solution. That's the only solution to the to the radical equation. So the answer to question number 19 is option number 2. Okay, so thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for your upcoming Algebra 2 exam, do give us a thumbs up. Your positive feedback is very valuable to us. If If you have any questions, comments, or special requests, just post it in the comment section below and we'll be more than glad to respond. Do not forget to subscribe to our video for updates to the remainder of this review series, and also visit our website mathgotserved.com on the New York regions for access to the transcripts to this video and other great support resources. Thanks again for watching and have a wonderful day. Goodbye.